This is our last example in this section, and it provides a different set of challenges. It's a little hard to pick out the pattern here because there aren't any squares, but if I look at the linear factors that I have a tangent x and I have a secant x. So they don't match. They're not the same trig function, obviously. And I have this constant thrown in here, so I don't have any common factors that I can take out. So that makes this problem a lot different. So you start to think about the relationships between the trig functions that you do have. And you remember that there's a relationship between tangent and secant. The only fundamental relationship they have is through the 1 plus tangent squared equals secant squared. So that's what we want to do. We want to make a substitution for either tangent squared or secant squared, but we don't have squares here. Although you cannot divide both sides by a variable, you can multiply both sides by a variable, which is what happens when you square this. The only thing that you have to pay attention to when you do that is that you have to check your answers in the end. Any other time, checking is optional. You can do it or you can just be confident in your answers. But here you must check, because when we square and multiply by a variable, there's the likelihood that we introduce solutions that are not valid for the original equation that we had. But we will get this relationship, this quadratic relationship between tangent squared and secant squared when we do this. First thing is to square this binomial. So square the first and you get tangent squared. Multiply these two together and then double it, and you get 2 times the square root of 3 times the tangent of x. And then square this term. Square root of 3 squared is just 3. And that equals just secant squared on the other side. Now I've got tangent squared and I've got tangent, and then over here I have secant squared. So I want to make a substitution, a trig substitution for secant squared. I want to call that 1 plus tangent squared so that I have everything in my equation in terms of tangent. So at first this looks quadratic, so I think, well, I'm going to get everything on one side. Let's start with the squared terms and get them on one side. I'm going to subtract tangent squared from both sides. Well, when I do that, I get 0 pairs on both sides, which means that my strategy changes, because now I'm not dealing with a quadratic. The only variable expression I have is this tangent x. Everything else is numbers. So this follows a linear format. I want to subtract the 3 from both sides. And if I do that, don't overlook this 1 right here. 1 minus 3 is negative 2. Then I want to divide both sides by 2 square roots of 3. So I end up with tangent x. When I simplify this side, the 2's are going to reduce. Remember, the negative is still in the numerator, and there's also a 1 in the numerator. Although it's tempting to rationalize this, don't do it, because this is not your final answer. This is the value for tangent x, and we want to find what angle makes this statement true. It's easier to use your reverse hand trick if you have 1 over the square root of 3 than if you rationalize it. So let's draw a picture and figure out where our angles are going to be. We know that tangent is negative in quadrant 2 and again in quadrant 4. So those are the 2 angles that we're looking for. Notice we want our angles to be in radians, and we want the answers that are between 0 and 2 pi. So you use your reverse hand trick to find a reference angle, and you find that 1 over the square root of 3 gives you a tangent value when x is equal to pi over 6. That's just the reference, because pi over 6 is in quadrant 1, and we don't have any answers in quadrant 1 because the tangent values would be positive there. But if we have a reference angle of pi over 6 in quadrant 2, that means we're starting at 6 pi over 6 right here. And if you back up 1, you get to 5 pi over 6. So that's one of my possible answers right there, 5 pi over 6. If I have a reference angle of pi over 6 in quadrant 4, 12 pi over 6 would be all the way around the circle, and you subtract 1, you get 11 pi over 6. Now remember that you need to check your answers. And there are different ways to do that. You can substitute in here, you can do it by hand, but I'm going to take the easy route and I'm going to use the calculator to check. When you take your final, you have to be able to show all of this algebra in this manner, but when it comes to checking, you can check however you want and you don't usually have to show your work on that. So let's take this to the calculator. I'm going to check by graphing, so I'm going to add a graphs page, and then even though my answers need to be in radians, I'm going to keep my my graphs page in degrees because it's easier to convert from degrees to radians than decimal radians to exact radians. So that's my strategy there. You can do that either way you want. I do need to change my view window to accommodate 1 revolution of the circle. Since my calculator's in degree mode, my min is 0 and my max is 360. And then it doesn't matter about the y values. Now in F1, I want everything on one side on my equation so that I can just look for the zeros. And remember, what I'm putting in is the original problem, which is tangent x plus square root of 3, and then subtract the secant x to the other side. Oops. Okay, not the best typist today, but there you see your graph. There's the equation. Make sure you have it typed in correctly. And we're looking at 1 revolution of the circle between 0 and 360 degrees, and we see that there's only one answer. There's only 1 0 right here. Clearly that's close to the end of the circle. It's close to the 360 degrees. You can do a graph analysis to find that 0, but I'm pretty confident that it's going to be this 11 pi over 6 right here. It's too far away from the end of the circle to be in the second quadrant, so I'm eliminating that answer. Now you do need to show on your algebraic solution that you considered both of these and that you eliminated that one. So we just have as our final answer x equals 11 pi over 6.